Alright, this is Vocab List 12, and we are starting with exothermic reaction. And we briefly touched on this last week when we talked about the evidences for chemical changes, chemical reactions. An exothermic reaction is a reaction that releases energy in the form of heat. We saw an example where light and heat were both released. We also did an experiment on Friday, and you felt the foam was warm. That makes that an exothermic reaction. So anytime a reaction feels warm or releases any sort of light, heat, or even combustion, you're talking an exothermic reaction. Okay, next one. Endothermic reaction. An endothermic reaction is the same, is just the opposite of an exo. And if you're looking at the first part of the word, exo and endo, exo means to give out, okay, outer, and endo means to go in. So an endothermic reaction is a reaction that absorbs heat. And if energy is absorbed, then the reaction would feel not warm but cool. And let's go ahead and add that to our definition. Feels cool. Okay. We also saw an example of that last week. All right. Third word, precipitate. Again, we briefly touched on this last week on Thursday during the notes, but a precipitate is a solid that forms from solution during a chemical reaction. Okay. And solution, we know, is when one thing is dissolved in another. So when you add two liquids together and all of a sudden a solid forms, that shows you it is a chemical reaction taking place, and a precipitate is the solid that is formed. All right, the law of conservation of mass. And if you're thinking, I've already seen this word before, you have seen the law of conservation of energy before. This is very similar. The law of conservation of mass says that in a chemical reaction, matter is not created or destroyed. If you remember, the law of conservation of energy said that energy cannot be created or destroyed. This is the same thing but with matter. Okay. Moving on. A chemical equation, that's what we're starting into this week, is we've looked at like the intro to chemical reactions, and they are written in what's called a chemical equation, and that's simply a short, easy way to show a chemical reaction. Using symbols instead of words. When we talk about chemical reactions, and we talk about water being formed from hydrogen and oxygen, we would be replacing the words hydrogen and oxygen make water with their chemical symbols, something like H2 plus, let's try that again, O2 yields H2O. My apologies for the handwriting. Alright, so that would be an example of a chemical equation. Alright, next word. The reactants. Reactants are the substances you have before a chemical reaction. And go ahead and write down the parentheses left of the arrow. This will help you. All right, and if we're talking about the same reaction we just talked about with H2 plus O2 yields H2O, the reactants would be the things we have before the arrow, before the reaction takes place. So the H2 plus O2 are your reactants. And the next word is products. You probably already know what the products are. They're the substances formed in the chemical reaction, and they're going to be on the right of the arrow. Make sure you write down the parentheses. That'll help you when you're studying. And if we're still talking the same equation, anybody know what the product will be? You probably guessed it. H2O is what's produced, what's made in this reaction. Okay, moving on. We got coefficients. You may have heard this word in math, so this word might be familiar, but it is a number placed in front of a molecule to indicate how many of each of those molecules will participate in a chemical reaction. While you're finishing writing, I'm going to rewrite this equation here. We're going to go into a lot more detail about this later, but in a chemical equation, because of the law of conservation of mass, I know that I have to have the same number of elements on each side. So when I actually do this equation, when we look at it when it's what we call balanced, the real equation looks like this. And you would read it 2H2O plus O2 yields 2H2O. And the big numbers, these guys right here, would be a coefficient. So the little ones, those are called subscripts. Those are not coefficients. It's the large number. Now we'll go into how to find coefficients later, but just know what a coefficient is. It's the number in front of the molecule, and it tells me how many of those molecules will participate in the reaction. Okay? Open system. An open system is a chemical reaction that is performed in an open container, just like it sounds like. And in an open system reaction, some of the product, what's produced, might be lost. And we know the law of conservation of mass says that nothing can be lost, that there's no matter created or destroyed. So I put this in parentheses because it is created, it's still produced, but if a gas is produced and it is an open container, that gas is going to escape and it's going to seem as if it's lost. So it won't really be lost, it really was still created, but in open systems, any gases produced will escape from the container. And that's the opposite of the closed system, which is your next word. And the closed system is in a chemical reaction that is performed in a closed container, just like it sounds like. And in this case, because there's a lid, because it's enclosed and nothing can escape, these are the kind of reactions we use to prove the law of conservation of mass. Because even a gas will still be contained in the container in this case, and in an open system it won't. So closed systems are really important when proving the law of conservation of mass, as where open systems are used more just to show a reaction or an example of a reaction, maybe showing what an exo or endothermic reaction looks like. The closed system is what you would use if you're measuring mass. Okay, synthesis. The last three words are types of chemical reactions, and synthesis is the first. It's where two simple substances combine to make one more complex product. And we'll take notes on this later in the week, but the way I like to write this is we have substance A plus substance B. So two simple substances, just letters by themselves, and they yield or combine to form substance AB, now bonded together. So in the beginning they were individual simple substances. They combined to make one complex product. Okay, the opposite of synthesis is decomposition. We talked about decomposition as one of the examples of chemical reactions. And this is the opposite. It's one complex product breaks down or breaks apart to make two simpler products. And this would be just the opposite. So if we were writing it in my AB terms, it would be molecule AB yields A plus B. So in this case, they separate. They break down into two simpler individual substances. All right, last word, and that is replacement. Replacement is the third type of equation, and that is where one element replaces, just like the name sounds, another element during a reaction. And what this does is it creates new combinations of the same elements. Keep in mind you have the same elements before and after because you can't create or destroy matter, but you're going to get new combinations of that matter. So creates new combinations of the same elements. And just to give you a quick example, again, we'll talk more about this later, so you can choose whether you want to write this down. If I'm using my letters, we've got A plus BC yields AB plus C. So if you look at this, you have A by itself plus the compound BC, and they react, that's what the arrow represents, and yield, now AB are bonded together and C is over by itself. So same elements, A, B, and C on both sides, but now in a different combination. Alright, and that is it. Go ahead and glue your vocab in your notebook.